As I said in the last video, we're going to break chapter or section 4.1 up into different segments to make sure we have reviewed well all parts of radicals. So we talked about before the parts of the radical, and today we're going to talk about operations with radicals. So I want to connect this to something that you already know. Our goal today is to be able to add and subtract radicals to write expressions in simplest form. So let's think about what we've already done with expressions and combining terms to write them in simplest form. For this bell ringer, it says simplify each of the expressions. Remember when we did this, we looked to the inside and saw that we were adding like terms in this case, which just means that we are looking for terms that have the same variable parts, right, and exponents. So x squared. We take the coefficient of 3 and 4, we add that together, and we end up getting 7x squared. Again, we look for another like term. We've got an 11x and a negative 5x, so we combine those coefficients. 11 minus 5 is a positive 6, and we still have an x there. And then this negative 3 that doesn't combine with anything is there on the end. So we've practiced combining them. Again, we look for like terms, and then we combine those pieces. They're not always in order, so if we look at this next one, again, this is addition, so I'm just going to combine the like terms. I have a 4x squared right here, and a negative 3x squared here at the end. So 4 minus 3 leaves me with 1x squared. You can write the 1 if you want to, or don't need to. Negative 3y and a positive 6y, so negative 3 plus 6 is positive 3, and we still have the y, and then this x, right, doesn't have anything to combine with. That's a like term. So notice to be like terms, right, they have to have the same variable involved for sure, and they also have to have the same exponent on there. So if I just have an x, that's not combining with the x squared. The x would not combine, right, with the y term. So it takes kind of two things to make them like terms. The same thing is true when we add and subtract radical terms. So in order to add two radical terms, they have to be what we call like radicals. Okay. Down below, we're going to define that. So like radicals are two radical terms. Two radical terms are called like radicals if they have the same index, and this is where that vocabulary is going to come in. So they have to have the same index to be like radicals. Okay, and so it can't be one or the other, both have to be true, and they have the same radicand. Okay, so here's some examples. On the left, examples of like radical expressions would be something like 4 square root of 3. Its like term could be negative 10 square root of 3. Notice that these are both square roots because the index is not written, so we assume it's a 2. They both have a radicand of 3. Those would be like radicals. Another example would be 2 cube root of 10 and 7 cube root of 10. So the radical piece there, notice it has both cube roots, and they both have a 10 on the inside. Now, terms that would be unlike, so I'm going to write some unlike ones here off to the side, would be like 4 cube root of 2 and 3 square root of 2. Notice that this index is a 3, so a cube root of 2, that's a completely different value than a square root of 2. If you were to put that in your calculator, the cube root of 2 is a smaller value. So in this case, they do not have the same index. Okay, so make sure we're careful with those. Most of the ones I'm giving you today, you'll have the same index, and we'll talk about what to do if they don't. Another example of non-like radicals would be negative 3 square root of 7, and let's say negative 4 square root of 5. So even though they're both square roots, they have the same index. One is the square root of 7, one's the square root of 5. So you can't say if I have negative 3 of these and I minus 4 more of these, because this is different than the other one. So these ones don't have the same radicand. Okay. All right, so when we are adding and subtracting like radicals, the first thing you're going to want to do, and this is what we practiced last time, so that we were ready, is simplify each radical term. So if you can and you need to build those little factor trees, you're going to simplify them and then identify which ones are like radicals, okay? Then you're going to combine like radical terms. And remember, when you do that, it's like when we add or subtract those like terms in the bell ringer. You add or subtract, right, depending on if it's positives or negatives, the coefficients, so the numbers in the front, okay? The radical part stays the same. So let me repeat that. You add and subtract the coefficients, and then the radical part, meaning the index and the radicand, stays the same. Okay. So jumping down here, if it's already simplified, oops, sorry, communication here. If you look at part A, you'll notice these are both cube roots. They're both 5 as the radicand, and they're simplified. I couldn't build a factor tree here. So all we do is have to say I have 3 of these, and I have 7 of these. So if I add 3 plus 7, I have 10 cube roots of 5. Again, being very careful to make sure that cube root is on the radical or in the radical, not out here on the 10. Notice on B, these are not like radicals, so it doesn't look like I can combine them. However, if I start to break this down using what we did last time, 12 breaks down into the factors, let's say 3 and 4. 4 can continue to break down to 2 and 2. So it looks like this is a square root, right? Our index is size 2, so we're going to have a group of 2's there. Now remember, when the 2 comes out, it multiplies by whatever's already out there. So this would be like a 4, and then that 3 is left over, so it gets put back inside. Now we can do the same thing with this term on the right. So we're just doing this one separately. So 27 has factors of 9 times 3, and we could go 3 and 3 there. Notice that gives us a group of 3's with 1 that's left over. So again, when you pull the 3 out, don't forget about the coefficient that's already there. So we pull a 3 out and multiply it by that 3, so we get -9, and then we have that leftover 3 that goes back inside. You'll notice once you've simplified, we actually have like radicals now. They're both square roots. They both have a 3 as the radicand, so we can now combine these. If I have 4 square roots of 3 and I subtract 9 square roots of 3, that would give me -5 square root of 3. Again, it's a lot like combining like terms with our x's and exponents. We just have radicals involved. All right, let's do a few more examples. For the most part, these are just various examples, so I'm just going to do a few of them here. Again, if you want to stop it and work through them and then check with even the posted key, you can do that. Again, we look at this first one. It doesn't look like anything combines. So we go ahead and we start to break these down. Again, you just do each one separately. We can't start combining into separate terms. But 98 divided by 2 would be like 49 and 2. And this would be 7 and 7. Oh, about crossed out my 2. So you've got a group of 7's there. So again, if you bring the 7 out, it multiplies by that 2. And we have 14 square root of, and you have that leftover 2 that stays inside. If we break down 72, that would be like 9 times 8. 8 breaks down to 2 and 4. Would be 2 and 2, so we broke down the 8 and the 4. And then if we break this down, the 9, we end up with 3 and 3. So if we look at this, it looks like we have a group here, and we have a group here, and then we have a leftover 2. So remember, when you pull this out, there's already a negative or like a -1 in the front of this term. So it's going to be negative. You've got a group of 3's, so a 3 comes out and a 2 comes out. 3 times 2 would give me 6. And then again, inside I have that 2 that's left. Then lastly, breaking down 32, that would be like 8 times 4, 2 times 2, 2 times 4, and a lot of 2's here. So we've got lots of 2's on this one. We've got a group here. We used that 4. We got a group here, and we have a leftover. So again, if I have a group, that's a 2 times another 2. So this one's going to be plus. Again, when you pull it out, remember there's already a 4 there, so when you pull these two 2's out, you've basically got 4 times 2 is 8 times 2 is 16. And then your leftover 2 stays on the inside. Notice now these are all square roots of 2. So we can actually combine all of these. So we're going to do 14, right, minus 6 square root 2. That would be 8 square root 2. Plus 16 square root 2 would give us 24 square root of 2. Looking at number 1, I'm going to jump down to these practice ones. Just remember if there's a negative out front and I'm combining these already both have square roots of 6. This is like having a negative 1 here. So when you combine it, you have negative 4 minus 1 of them. That would give me negative 5 square roots of 6. Okay, so don't ignore that there is a negative 1 out front. I want to look at number 5. If we break this one down, notice this one's a cube root. So 3 cube root of 2, that's as simplified as that goes. It's a little squishy there, sorry. But the 54 can break down to 9 and 6, 2 and 3, 3 and 3. So this one we can break down. Notice we need a group of 3 because the index is a 3. So we're going to choose these to be a group, and then you've got that leftover 2 right there. So again, when you pull that 3 out, recognize there's already a negative out front. So we're going to have minus 3 or negative 3, and then that leftover 2 goes inside. Now here you have 3 square root of 2 minus 3. Oh, I apologize, cube root of 2. If you have anything minus itself, this is where those terms would cancel out, is what we often say, but they add to 0. So that's just 0. Okay, some of them that I did, all the terms it seems like added together. Notice on number 6, you have 2 square root of 18 and 2 square root of 18. If you want to add those now, you can. Even though we can simplify the 18 instead of building like 2 different trees that look identical, we could add these first and then simplify. So if I have 2 square root of 18s and 2 square root of 18s, I could do 4 square root of 18. Now I only have to simplify that square root once. I'm going to bring this one down, so minus 2 square root of 12. Once I've done that, then I go ahead and break this apart. So this is like 9 and 2 and 3 and 3. So again, that group comes out, multiplies with the 4, so that's 12 square root of 2 on this term. The 12 over here can break down, 6 and 2, 2 and 3. That gives us a group there with our 2's. So again, when the 2 comes out, it multiplies by what's already there. So 2 times negative 2 is negative 4. And then that leftover 3 gets to go back in. Notice this one now, you have 2 terms. That's okay too. This one's as simplified as it can go. So is this one. And they're still not like radicals. So we leave them side by side. Okay. That's adding and subtracting radicals.